bullet of mass 80 grams is fired at 220 meters per second into a 1 kilogram block. The bullet is embedded into the block and the block rises. By using the conservation of momentum, find the velocity of the bullet block mass after the collision. Right, so what's happening here is we have our bullet and it is going at 220 meters per second and its mass is 0.08 kilograms, and then the 1 kilogram block is at rest, and then afterwards the bullet becomes embedded into the block, so the block now has a mass of 1.08 and that will move away at some speed which we'll call x. So conservation momentum says m1 u1 plus m2 u2 equals mv. So here we get x equals 0.08 times 220 divided by 1.08, and we get 16.296 meters per second, and that's for part A. So now 16.296. So now part B, use the conservation of energy to find the maximum height. So the energy down here will be the same as the energy when the block swings up to its maximum height, which means it's at rest, which means it only has potential energy, and that should equal the kinetic energy down here. We can get the kinetic energy because it will be a half mv squared. That's equal to potential energy, which is mgh. So by dividing I can get the h. So we'll square that, divide by 2 times 1.08, divided by 1.08, divided by 9.81, and the height is 13.5 meters. So provided that the string was long enough, it could swing up to a height of 13.54 meters then, and that's the maximum height then.